This is our lecture number 1 of design and analysis of algorithm. In this lecture, we will study different topics of algorithm. First of all, let's start with the basic definition of algorithm. What is algorithm? Algorithm is a finite sequence of set of physical possible steps performed in correct possible order for solving a computational problem. Right? Again, finite sequence of set of physical possible steps performed in a correct possible order for solving a computational problem. It takes you from one consistent state to another consistent state where both of these states may or may not be the same. Algorithm must be language independent. Now, what is the interpretation of this definition? Finite sequence of set of physical possible steps, there we could have any problem, and when we have the finite steps to solve any particular problem, and when we write those steps in the correct possible order, so we call it an algorithm, right? Further, it takes you from one consistent state to another consistent state uh, where both of these states may be same or may not be same. But one thing is sure, for any algorithm, it must be a language independent. Algorithm can never be a language dependent, right? Because it is a logic. A logic we can implement in any language: C, C++, C sharp, VB, Python, etc., etc., based on the syntax of that corresponding programming language. The other definition of algorithm could be, you can see that an algorithm is a sequence of unambiguous instructions for solving a problem for obtaining a required output of any legitimate input in a finite amount of time. The second definition could be an algorithm is a sequence of unambiguous instructions, means the instruction must be clear, instruction must not have any ambiguity for solving a particular problem for obtaining a required output based on the given input. So this could be the second definition. We may also retrieve so many other definitions of algorithm. For now, we have studied these two definitions of algorithm. Here is the diagram. For example, you have a problem. When you write in a in a correct possible order, when you solve that problem in correct possible order, so it will become algorithm. And finally, when we code it in any programming language, so it will generate output based on the given input, as you can see the diagram. So this is a simple notion of algorithm, or a diagrammatic view of algorithm, right? Let's move on. Properties of algorithm. So student, one must keep 4 to 5 points while designing an algorithm. Number one would be, it should be finite. Algorithm must be finite. Algorithm must not be an infinite, right? Number second, it should produce at least one output, right? Third, it should take zero or more input, right? Next, it must be deterministic and give the same output for same input. What does that mean? Means that it must be a certain output for the same input. Output must not be uncertain. Output must be decisive. That's what deterministic means. It must generate an output based on the given input. And last but not least, every step every step must do some work, means every step should be effective. There shouldn't be any irrelevant step. Every effect must be of some use. Every step must be of some use. There shouldn't be any irrelevant step. Right? Let's move on. So how many types of algorithm do we have? We have so many different types of algorithm. Number one is brute force algorithm, recursive algorithm, backtracking algorithm, searching algorithm used for searching, sorting algorithm used for sorting, divide and conquer algorithm, hashing algorithm, dynamic programming algorithms, greedy algorithms, randomized algorithm. These are the types of algorithm. We don't have to go in detail right here, right now. Further, I will, by the time I will explain you the different types of algorithm, I will tell you in detail what are the purposes of these different algorithms. Right now, I'm just telling you from bird eye view what should be the types of algorithm and how we can segregate algorithms or differentiate algorithms. So here we have different types of algorithm. Now, for example, the important thing we should notice while designing an algorithm, first of all, you have a given problem, right? As you can see that I have selected this. So we can have a solution number one of problem number one, right? And to get that solution, we could apply algorithm number one. And to execute that algorithm, we can have machine number one. And that machine obviously will take some time. We call it time number one, right? Problem one, solution one, algorithm one, machine one, and time one. Which means I will have a problem. To solve that problem, I will apply some algorithm. And to execute that algorithm, I must have some computational device or machine. And obviously, when I execute that algorithm in a computational device, I will end up with some computational time. So we call it a time number one. Suppose we have problem number two, and we could be a solution of that problem, right? Right? We could be a solution two of that problem, and we have retrieved that solution with the help of algorithm number two, and we have executed the same algorithm in machine number two, and obviously we will end up with some computational time in problem number two. So here we have two different examples. Now T1 is less than T2. Why? It might be possible T1 will have less time than T2. Why? Because machine M1 is better. T1 could be less than T2. Why? Because algo 1 is better. And T1 could be greater than T2. Why? Because algo 2 is better. So what does that mean? It means we can have three possibilities. Listen carefully. Time 1 should be less than time 2 because of machine. Time 1 should be less than time 2 because algorithm 1 is better. And time 1 should be greater than time 2 because algo 2 is better. So what have we understood with these examples and these scenarios is, so with the above example, we came to know while comparing two different algorithms, we make sure problem and machine must be constant. What does that means? While comparing two different algorithms or three different algorithms, we should keep constant machine and the problem. Why? When we keep constant machine and the problem, then it will be the pure comparison of algorithm. It will be the it will be the analysis of the algorithm. It will be the analysis of it will be purely the analysis of the logic of two algorithms. Getting my point? Let's move on. So here is a basic example of algorithm for beginner. Now suppose we have a problem. We want to make a cup of tea. Algorithm, step, methods, and the result. So if I ask you to make a cup of tea, here we have a given problem, making a cup of tea. What should be the steps? Take an empty cup. Another step should be add hot water. Third step should be add tea. Fourth step should be obviously add sugar. Fifth step should be add milk. And the second step should be mix or stir. So by the end of when we go through these steps, we will finally get the cup of tea. So the resultant should be the cup of tea is ready. So this is a generic example of algorithm, the real life example of algorithm. Let's move on. Before going to a technical example of algorithm, let me explain you the few algorithms notations. First of all, algorithm name, it should be in capital form. Parameters, it should be enclosed in parenthesis. Introductory comment, description and purpose of algorithm. Steps, finite steps. Comments, each step starts with the comments enclosed in square bracket, which defines the purpose of step, input statement and output statement. So these are the notations of algorithm. I would strictly recommend at the initial level you should follow all the notations, but when you will be in practice, then it would be your choice whether you want to follow the algorithmic notations while designing algorithm or not. Let's move on. Let's take a technical example of algorithm. For example, we want to add two numbers. So here we have an algorithm for adding two numbers. So first of all, according to algorithmic notation, this is the name of algorithm. Algorithm sum, number 1, number 2, result. So here is the description. This algorithm is used to read two numbers and print its sum. Step 1, read number 1 and number 2. Here is the algorithm, read number 1 comma number 2, which should be written in parentheses. Step number 2, calculate sum. Result is equal to number 1 plus number 2. Step number 3, display result. Write result. Step number 4, finish and then exit. So here is the technical example of algorithm. How to code that algorithm we will study in future. How to code that algorithm in C++ or C# or Python, etc., etc. Right? Now let's move on to fundamentals of algorithm problem solving, or how to design an algorithm. Now We can understand this topic with the help of this diagram. Here we have a diagram, fundamentals of algorithm problem solving. First of all, we have to understand the problem. Decide on computation means exact versus approximate solving, or choose the appropriate data structures, and then finally algorithm design technique, and then design an algorithm. Now, if there is a need, we should move on to this level again and again. As you can see that we have a arrow, and when we have successfully uh, achieve this phase, then we have to design an algorithm. Then the next phase would be prove its correctness, then analyze the algorithm, and the final stage would be code the algorithm. So let's discuss it one by one. What does that mean? That's what we call the algorithm design and analysis process, or a fundamentals of algorithm problem solving. Let's discuss it one by one. What does actually means understanding the problem? Understanding the problem. From a practical perspective, the first thing you need to do before designing an algorithm is to understand completely the problem given, read the problem description carefully, and ask the question if you have any doubts about the program. So basically, in this step, we analyze, not actually analyze, we understand the problem, remove the ambiguity, read the problem description carefully again and again, ask question if you have any doubts, and when you end up with any uh, unambiguous statement, you end up with any without having any query, then you should when you completely understand the problem, then you should move on to the second phase. What is the second phase? In this phase, we actually ascertain the capabilities of a computational device. What does that mean? Once you completely understand a problem, you need to understand the capabilities of the computational device the algorithm is intended for. As I have explained you before, while comparing two different algorithms, the first thing we make sure the problem and the machine must be constant. So first of all, we have to ascertain, we have to make sure which computational device we are going to use, i3, i4, i5, i7, i9. But once we chose the computational device, we make sure that okay, we should keep that computational device constant for all the uh, upcoming algorithms, right? For at least same type. Next point would be algorithm design techniques. An algorithm design or strategy or a paradigm is a general approach to solving a problem algorithmically that is applicable to a variety of problems from different areas of computing. Now we have different algorithm designing techniques. uh, we cannot say that okay, which technique should be applied on which problem. It depends on the the problem definition. So we could have so many algorithm design techniques like brute force, recursive algorithm, backtracking, searching algorithm, sorting algorithm, divide and conquer, hashing algorithm, greedy, randomized algorithm, etc., etc., etc. So we cannot pass a sweeping statement. It totally depends the nature of the problem and the problem definition. कि which technique should be applied on which algorithm. Next one is proving an algorithm's correctness. What does that mean? Once an algorithm has been specified, you have to prove its correctness. That is, you have to prove the algorithm yields required result for every legitimate input in a finite amount of time. For some algorithm, proof of correctness is quite easy, and for others, it can be quite complex. A common technique for proving correctness is to use a mathematical induction because an algorithm's iterations provide a natural sequence of steps needed for such proofs. Now, what is a mathematical induction and how can we prove algorithms while using the mathematical induction? Well, mathematical induction is a mathematical technique which is used to prove statements, formula, or theorem, and uh, whether the theorem is true for every natural number, that formula or that theorem or that algorithm is true or false for every natural numbers. Right now, you just need to understand the basic concept of mathematical induction from bird eye view, which will be applied in different examples later in this course, right? So the last step would be analyzing the algorithm. Second last step, analyzing the algorithm means there are two kinds of algorithm efficiency: time and space efficiency. Where time indicates how fast the algorithm runs, space efficiency indicates how much extra memory the algorithm needs. Let me further elaborate the techniques of algorithm, the parameters or the variables of analyzing the algorithm. Now, the time efficiency means it cannot be easily resolved because, as I just explained you, time could be different because of so many reasons. Time could be different because the problem 1 is shorter than problem 2. Time could be different because the PC 1 is faster than PC 2, right? And time could be different because algorithm 1 is better than algorithm 2. So it cannot be easily solved. As I just said, you need to keep time, you need to keep machine and problem constant while analyzing the algorithm. So, because it depends on the multiple possibilities. What about the space complexity? Space is amount of memory required by an algorithm to run to reach to the completion, right? You can increase memory size when input is an increase, which means this space problem can be solved. So whenever we analyze the efficiency of algorithm, uh, you need to understand the analyzing the basic two parameters, the basic two uh, the variables to analyze the efficiency of algorithm is time and space. Time means the computational time, how fast the algorithm runs, and the space means how much space, extra space or memory the algorithm needs. So finally, we after going through the above steps, we finally code the algorithm. Now it's up to you, okay, whether you want to code in C sharp, C++, Python, Visual Basic, etc., etc. Right? So by the end of this topic, I conclude my lecture number 1 of algorithm.